Right, evening folks, yes. So yes, I'm a visual effects research engineer. I work at Lucasfilm in San Francisco. Keeps me busy. So yeah, today I'm just going to talk about something that I don't actually do very much of day to day, but I've sort of taken a fair interest in because I think it's a cool topic, and which is motion capture. And it's, I guess it's modern use in film nowadays. So, is this working? Nope, okay. So, why would we ever want to do motion capture? So, if you look at how animation was traditionally done in typical animated movies, what we do is animators would draw out a little cell and they'd draw out a character and they'd go from frame to frame to frame to frame to animate the character sort of moves as they go across the screen. So that translated over into animating 3D characters. So, for example, typical stuff you see in Pixar movies, where what they do is that they do this thing called keyframing. So rather than animate every single position for every single frame, 24 times a second, what they'll do is that every sort of key movement, they will basically mark the position. So, for example, they're essentially a digital marionette. They'll pick a position and then they'll go to a couple of frames later and they'll pick the next position. And the computer will automatically interpolate the motion as it goes from one sort of frame to the next. So the thing is that why we want to go with motion capture versus just straight up animation is that there's sort of two camps. So if you look at how Pixar do the job, Pixar are very sort of in fact, they're very firmly in the keyframing school of thought. And the idea is that they think that to sort of get sort of this natural look, you need to have a human touching every single frame, effectively. So what they can do is they can put a lot of artistry and a lot of exaggeration into the movements of the characters. But if you look at the other school of thought, you've got characters who are in effectively like you're dropping computer-generated characters into a photorealistic movie. So if the argument is that if you have an animator doing the movement, it doesn't quite fit. So with motion capture, what you can do is you can capture a lot of subtle movements that you wouldn't normally get with hand animation. It's just simply because the human body does a lot of sort of complex, subtle things when it moves from one frame to the next. So for example, there are little things that are really hard to capture in animation. So if you look at how most animals and like how most humans, how the locomotion goes, when you're actually stepping, the foot actually slows down. So when it hits the ground, it actually slows down, so it actually hits the ground with a minimum amount of force. And if you look at sort of computer animated characters in movies from, I guess mostly from the 90s and sort of the early 2000s, you'll see that when the characters are hitting the ground, they're really thumping the ground really quite hard, and it just doesn't look quite right. And if you compare that with a motion captured actor has got much smoother motion as they go through. So the other thing that you can do with motion capture is that you can take the motion capture data. So somebody who's a human actor, they can drive the performance on non-human characters. So Animal Logic, who are down the road, they actually used human actors to drive the performance of the penguins in Happy Feet. It sounds kind of silly, but the actual tap dancing performances were directly driven from actual tap dancers. And what they did was that they used a bunch of fairly neat algorithms to remap it so that the physiology of the human actors were remapped so that they matched the penguins. But effectively, they were like human performances. So I remember seeing, I don't have the clip here, unfortunately, but I saw a great clip of them, motion capture actors basically pretending to be seagulls. So the way they'd go around it was that they'd be wearing the motion capture suits and they're actually wandering around like this to sort of emulate the performance of the seagulls. So I thought the result looked pretty good, but the other argument is that you save a bunch of time because the animators are not doing every keyframe, but I don't think that's actually true, but I'll get back to that a little bit later. So the actual motion capture process is, it actually requires a fair bit of technology, unfortunately. It'd be nice to be able to say, you just point the camera at the actor. Like, I mean, if you look at how a movie is typically filmed, it's with a single camera, and the single camera points at the actors, and you get the information, it comes in, and you're ready to sort of work with mocap. But the thing is, to get a really good result, you actually need multiple cameras. So that's actually a picture of the motion capture stage at work, and you can see just around the edge of the room, and you can see in a little bit more detail on the other side, you've actually got multiple cameras that are capturing information from all around. And it's just simply got to do with stereo vision. So for example, if you're just seeing with one eye all the time, you don't have depth perception. So you don't get a really solid idea of where everything is in space. But if you have more than one camera, you can get a really good triangulation of where everything is in space. And if you've got cameras that are all the way around, what they can do is that they can track multiple subjects and also track them from multiple different angles. So that's the idea. So most motion capture stages and most motion capture processes usually involve at least 2 cameras. So what happens is that in a typical mocap process, you have the camera that tracks key points that are on the actor. Now I'll get into a little bit more detail in a minute, but the way we sort of typically see it in like movie breakdowns is that you see someone wearing the spandex suit with the little ping pong balls on it, but it's also possible to do it without that as well. But what you have is you've got these what we call features on the individual, right? So typical feature would be, say, for example, like a hand or an elbow or key points on the face. And these points are used to drive usually a skeletal rig, which is considered, well, that's the technical term for them, it's just bones. So, and the bones represent sort of like, it really is like, it maps actually fairly well to human, like for human characters, it maps directly to the anatomy. So you've got these you pick hard points that are on the human actor, stuff that doesn't typically move or slide around. So for example, like a bad choice would be picking a point on your forearm like this because your muscles move around. But a good point to pick would be the elbow, because that's a nice hard point that doesn't slide around when you move your arm. So you've got these hard points that correspond to points that are in the computer model, and they drive the skeletal or the bone rig. And then the bone rig in turn drives the character. So for example, like I've just got, if you can see there's just a character there just on the right hand side. You've got multiple bones, and the bones will then control sections of skin. More advanced models, the ones that are sort of typically used in sort of high-end visual effects, they actually don't just consist of bones and the skin rig. They also have musculature which goes under the skin, and then the skin is usually this simulated cloth model which goes on top of the muscles as well. So it's possible to sort of take your human performance to drive a fairly complex model. And again, it doesn't necessarily have to be a human character. You can sort of exaggerate the performances, or you can exaggerate the proportions, or even just sort of change their anatomy altogether. So the mocap process is, it really requires solid cleaning of the data. I'm sure some of you folks have seen this, but this is a really good example of what happens if you don't clean up the data. So what's happened here is that I don't know the guy who produced the video. He's a producer in LA. But what's happened is that the data has come in and it hasn't been calibrated and it hasn't been cleaned. So when I was talking about how the data that comes in from motion capture, it needs to have it. You need to clean it up. You need to remove all the noise. See that head like that? That's just plain old noise that hasn't been filtered. It's a little silly. Anyway, so that's a fairly good example of what happens is that's what I was talking about. Like, so there's this argument that motion capture was going to save artists a whole bunch of work where they wouldn't have to sort of constantly be going in and sort of keyframing every frame. But when the data comes in, it still requires a lot of cleaning, or it still requires a lot of massaging to get something that's usable. So once you get the data that comes in, the information that comes in about all the points can also be blended with traditional animation. So what happens is that, okay, so this was a fairly good example, actually a fairly bad example of this was I think the first Spider-Man movie. So they actually blended motion capture that would try to sort of, so they'd start with a motion captured frame, so somebody like they had the character running along, and then he did this impossible stunt, which was keyframed animation. And sort of blending between the two is possible, but it's very hard to get that right because, like I said, it's very hard to capture sort of weight and the way that the sort of character transfers weight from one foot to the other or swings from one place to another. But it's done all the time now, right? So you take your motion capture data, and then you could, for example, you could take your motion capture performance. So it starts with something that's natural, and then the character does some sort of crazy stunt or whatever, and that's typically that's typically animated because it's not like another reason you use mocap is because it's too expensive or too dangerous for the actor to do a stunt on the stage, so they decide to sort of do that via animation instead. Um, the other sort of important thing to differentiate between is that we've got, I guess, there's two classes of motion capture now. So there's motion capture as we sort of traditionally know it, which is sort of the performance of the actor's body. But there's this thing called performance capture now as well, where what you do is you try to capture everything. And what that typically involves is that the actor will wear a rig as well, so that it captures their face as well. So you're basically capturing two different performances. You're capturing the performance of the actor as they walk around, but you're also you also have a separate rig which they wear, which basically takes very high definition video of their face, and their face will also have markers on it, and they will capture that performance as well. So that was used for actually Andy Serkis uses this a lot at Weta. So what happens is typically they'll have a separate camera rig that sort of tracks his face, so they can use that to sort of drive Golem or Shin Kong or whatever. So I just wanted to sort of show a couple of concrete examples of the way this is done. So this is two examples of just plain old marker-based motion capture. So what you've got is that the actor, so Bill Nye on the left and Dan Jr. on the right. So there's two types of different sort of markers that they're using. So you've got Bill Nye there. He's wearing the on his body. You can see you've got the just plain old reflective ping pong balls, and those are sort of tracked in space using multiple cameras. But he's also wearing a special headband as well. So what happens is this is an example of like a hybrid rig. So where on the stage you've got multiple cameras that are around, but you've also got several witness cameras that are tracking his head via those markers around his head, and they can sort of figure out where that is in space. It also works fairly well outside. So for example, that was shot in, I think, at Randy's Donuts in LA. And you've got those bands that are around his limbs. And that's something, because they weren't on a motion capture stage, they're able to use those outside without sort of special, without the special sort of multi-camera rig. But down at the base where they were filming him, they had multiple witness cameras to sort of figure out where he was in 3D space. And the idea is they use that to sort of place, or to digitally insert the armor that he was wearing afterwards. So the other type of marker-based technology that's used is what's called active markers, and they're basically just flashing lights. And the flashing lights will strobe at different frequencies to identify where they are on the body and also which actor it is. Typically, they don't strobe using visible light, so they use something like infrared light, and they use a special a camera that's tuned to infrared just to capture it. The nice thing about that is that you can film it, and the markers aren't so obvious, right? So the actor doesn't feel like they're in sort of the middle of this science experiment, basically, and they can have sort of a much more natural performance. But it's more expensive, but you end up with sort of a more comprehensive result that way. So the nice thing about the marker-based technology is that it's sort of cheap, relatively cheap, and it's easy to implement. But the cons is that like I said, you've got the problems with these markers where if you're not very careful about where you place them, they may slide. And also, if you've got one take one day and a take another day, you've got to make sure that where the markers are placed between one day and the next are very, very exact. So if they're just wearing a suit, things may slide around a lot. So again, that's why you need to massage the data as you go through. So the next sort of generation of technology is doing this via markerless technology. And what you do is that you, so the one that's along the bottom there is that the actor or actress get made up with this phosphorescent makeup that only shows up in UV light. So what happens is that there's a black light that's shone on them, and you've got a UV sensitive camera. And what happens then, what you get is that funny sort of speckled look. The thing is that is actually very friendly for algorithms that can then sort of figure out the depth of the character, and they can extract the geometry entirely. So you can very, very accurately, for example, mark where the corners of the mouth are, what the eyelids are doing, sort of getting all the little wrinkles in there, and that can be used to drive the performance directly. That's really nice, but again, it's even less obtrusive, so it doesn't get in the way of the actors, the actresses. They feel like they can just sort of perform without having all this stuff on them. But again, you sort of need to do it on a special stage, and it's very, very expensive. And there are sort of, I think the way that we're heading now is doing this entirely via computer algorithms. So you drive, you've actually just got a camera that's on the actor or the actress. You've got actually several cameras just to figure out where they are in 3D space, and then it will try to automatically figure out where the eyes are and where the lips are, just via sort of facial, I guess, sort of high-end facial recognition technology and sort of shape recognition technology. That's great, but I think it's probably still a few years away before it ends up being something that's mature and what we call sort of production ready, something that will produce consistent results every time at a high enough quality. So I wanted to show you sort of a couple of concrete examples of the facial mocap. So this was done, oh gosh, when did the second Pirates movie come out? It was like 5 or 6 years ago, right? So again, that's sort of Bill Nye in his setup there. So what's happening is that this is being used to drive what's called a puppet rig. So the marks that are on his face are being used basically to place Davy Jones. So it's not actually being used to drive the performance. So what happened was that the markers were used to sort of roughly place where the mask should be, but then the actual sort of emotion and the, I guess the way that sort of the character moved and talked was animated by hand. But the result was sort of pretty seamless and it worked sort of fairly well. The next generation from that was actually, again, like I said, just talking about this, so this high-end facial motion capture, where what happens is that the actor or the actress, they'll actually have a camera which hovers in front of their face. Some companies actually use 2 cameras. Weta, I think, at least for Avatar, they used 1 for most of the actors and the actresses. And so you can see they've got those marker points that are on the face. So what happens is the marker points are used to drive key points on the model, and then that will drive, for example, like there's, if you look like underneath that, there'd typically be some sort of musculature and some sort of cloth model which goes on top of it to represent the folds of the skin. And you have a little bit of physics in there to sort of get the wobble in the lips when they talk and stuff like that. So I guess that's where currently things are at, and they were sort of trying to move away from even that to have it so that the cameras are further away, that sort of they don't get in the way of the actors and the actress when they're trying to perform. So in the future, where are we heading? I think we're going to be looking more and more at sort of, I mean, it sounds a bit sad, but the thing about it is that if you use motion capture, there's a lot of room for the director to change the camera angle later on and to sort of tweak the performance and get more of the visual effects done at an earlier stage. So we're looking at these concepts of virtual sets that was used a lot on, actually Weta uses it a lot. So if you look at Tintin and a couple of the ILM shows as well, we have these sets where the director will walk around with a virtual camera and they'll be capturing the actors' performances, but what happens is then they can replay the performances with the virtual camera they hold in their hand. Typically it's like a tablet that has a couple of markers on it, and what they can do is they can change the angle and they can change the composition later on. So the idea is that you can do much more shooting all in one go and then later on tweak it to be exactly what you want. The other thing is that you can sort of, I guess more like in the animation world, you can take one actor's performance and then combine it with another actor's performance from another take and combine all these things together to get the final result. The other thing is that we're going to see more motion capture sort of actually at home and sort of more consumer grade stuff. I think the stuff that's being done with Kinect is fantastic. So it's very easy, like, I mean, something you can do already. You can get, pick up a Kinect for like 100, 150 bucks, and there's a bunch of open source packages that you can get where it will actually do, like, you know, very basic motion capture for your face or your body, and you can plug that straight into an animation that you're doing at home. The other thing that's sort of kind of scary and awesome is automatic face replacement. So there was a great paper, it's starting to sort of get to a stage where it's sort of fairly mature and fairly automatic. So there was a great paper that was presented at SIGGRAPH last year where they presented a talk on basically doing this automatically. I mean, and coping with the fact that, for example, like a face that's shot in one lighting scenario is remapped so it looks correct when you take that face and replace it in another scenario. So that's sort of going to be kind of interesting as well, and it's also going to raise the possibility of, in the future, for example, of taking someone who's deceased and sort of reanimating them for a performance later on and doing it in sort of a fairly automatic, doing it in a sort of a fairly automatic way. And there's all sorts of ethical and legal questions that come up with that. So it's going to be interesting times. All right. And that was that. Any questions? Go for it.